Hi there, welcome back to our last part of the introduction. So now I'm going to talk about intelligent agents. Essentially, what we'll do is we'll introduce this new piece of AI here called an intelligent assistant, a personal agent, for example, a chatbot. So the knowledge worker now can interact with the personal agent instead of directly accessing this knowledge base. Yeah, in the previous part, I showed you the technology behind it, knowledge graphs, and you've seen that this gives you the technology to combine different pieces of information, structure them, and connect them with other knowledge resources. But this is not exactly usable for a human. Writing queries against a knowledge base using a query language is nothing for a normal end user. So rather, one common paradigm of interacting with an AI system nowadays is through a personal agent that could be materialized, for example, in form of a chatbot. So that's the idea of an agent, also called an intelligent conversational agent. This is a program, an AI program, that can interpret and respond to statements made by users in a natural language, like talking in English, French, German, or other languages. Now, when we talk about chatbots, you'll see that this is not just a single piece of technology, a single approach to building a chatbot. You'll see there is a huge variety and complexity in how you can build a chatbot. As a first classification, we can distinguish generic versus goal-oriented bots and retrieval versus generative bots. So retrieval versus generative means that in retrieval-based bots, essentially it retrieves all the answers it needs from a kind of knowledge base. You ask about what date was Bill Gates born, and then the agent will retrieve the knowledge from the knowledge graph, from the knowledge base. This is the standard technology that's used nowadays, but with modern deep learning technique, it's also possible to generate new answers. So for example, now if you ask an assistant like Siri or the Google Assistant, please tell me a joke, it's not actually making up new jokes, it's just retrieving a joke from its database. But with modern AI techniques based on deep learning, systems can now actually make up new content. For example, new jokes or new stories or new cooking recipes. So this is the first difference. And as you can imagine, generative AIs are way more complex and complicated than retrieval-based AIs. We'll actually look at this a little bit towards the very end of the course. We'll talk about deep learning techniques and how they would work in a context like this. The second dimension is what type of conversation you have. Is it about a closed domain or an open domain? So closed domain, you have an agent that talks about something very specific. And this is what's typically deployed nowadays in companies, organizations. An agent that can help you to open a new account or can answer a question about what time a movie is going to run or something like this. So they can only work in this very closed domain. And then obviously you cannot ask the movie agent about opening a bank account. They have no idea. On the other hand, an open domain bot is something you can basically talk about anything. So chatbot, yeah, you can talk about any topic, any concept that you would like to check about. And again, you can imagine that open domain is a lot more complicated to implement than closed domain. So there is a big variety in what you ask from a chatbot, but overall, we can classify them using a similar architecture. We have some kind of front end. Typically, these agents integrate with one of the existing channels that you have. For example, a chat application a messaging application, and so on. And obviously, since you talk to them in natural language, they have to have some kind of natural language processing layer. I mentioned also in the course outline introduction that we're not really dealing with spoken language. For transforming spoken language into text, there are libraries out there that you can also use. So basically speech to text translation. But here in this course, we are leaving this part out. We just assume you already used speech to text, and then we are only dealing with the written natural language. And then they need the knowledge. If you ask this agent a question, they have to retrieve the knowledge somehow. So they have some kind of knowledge base. This can come in different format. It can use a knowledge graph, or it can be a simpler content management system. And typically they also have a separate data store where they, for example, store information about the history, the context, have some analytical information. So this is sort of dynamically changing information. For example, if you have an agent that helps you making a flight reservation change, then it has to have access to your actual flight reservation to be able to make that change. Chatbots have a long history in AI. So they actually go back to an even older concept that's called the Turing test, invented by Alan Turing. And this was one approach to dealing with the question, what does it mean to be intelligent? There was really no agreed definition for intelligent. And Alan Turing had the great idea that we could just sidestep this question of what is intelligent or not by making up a test that would help us to distinguish an intelligent machine from a non-intelligent machine. And the idea that he had was that we have this setup where one person interacts with both a human and a computer, but they would not know which one is which, and then basically chat with both of them. And if the chatbot is able to convince the other person that he is human, then this would count as intelligent. So at that point, the AI would count as intelligent because it was able to give answers at least as good as a human would. So this was sort of one of the very early ideas in AI, and the very first real chatbot was called ELIZA. It was developed in the early 1960s. So this was a bot that simulated a psychotherapist. So you could come in and talk about your problem. You are stressed because you have to work from home all the time. And then it would give you advice based on what you talked about. I'll talk about ELIZA a bit more in a minute, but this is something you should try out. It's very old technology, but it's very interesting what this bot was able to do with the technology of the 1960s. And it had a big influence on the field of AI. A bit later, sort of as the opposite to the psychotherapist, there was a bot called Parry, which simulated a patient. So a schizophrenic patient. And then what people tried out, obviously, is to let these two bots talk to each other. So the AI schizophrenic patient had to talk to AI, the psychotherapist bot. And online, in a couple of places, you find some examples of this conversation, which usually didn't end well. A way more advanced chatbot was Alice, which could talk about all kinds of questions. This was one of the bots that was developed for challenges where people would compete against each other using bots. So sort of an implementation of this Turing test. And this was a bot that did quite well. It did not fool anyone that it's human, but it was one of the more advanced bots, a lot more advanced than these early ones. So this was all done in research. This was early artificial intelligence research starting from the 60s to the 90s. And starting roughly in the 90s, the technology became mature enough to do something useful with them. All these early examples were sort of experiments, research, and some of them were just made for fun, for competing in these competitions. But starting in the early 2000s, they became a lot more interesting from a commercial perspective. And probably the most famous, the best known example is Apple, that came out with their assistant Siri on the iPhone in 2010. Siri was actually developed by a startup that was bought by Apple. I'll talk about Siri a bit later on. But this was an example on how you can integrate a bot that can understand you and then actually do something useful for you. For example, sending messages or setting an alarm on your phone. A lot more complicated chatbot was IBM's Watson, which you have probably heard about and remember. That was the chat system that was able to compete on the Jeopardy game show competition, and it actually beat all the champions on this game show. So here I linked a short video from this Watson Jeopardy competition on the Moodle website. I recommend you have a look at this. It's just a couple of minutes long. After Apple brought Siri onto the iPhone, all the other tech companies joined not much later. Google had the first version of their Google Assistant, and Microsoft. So after Apple had their assistant, which was limited to iPhones, the other 10 companies started joining in. And one of the next one was Google with their assistant, published in 2012. And Amazon with their Alexa, which came out 2015. Microsoft in the same year joined with Microsoft Cortana. And yeah, these are the major players that are around nowadays. There are lots of others. Samsung has their digital assistant and so on. So this has really exploded in the last couple of years. Speaking of Microsoft, there was also a famous example, which was very short-lived, which was Microsoft Tay. Maybe some of you remember this. This was an experiment of releasing a chatbot on Twitter, which could learn from the messages other people sent it. So it would not just write messages, but it would look at the tweets other people sent it, and then compose new answers based on this knowledge it obtained from others. So I'm not sure who exactly at Microsoft thought it was a good idea. They probably imagined everybody would just have high-level philosophical conversations with Tay, but this is not what happened. People started chatting with Tay and tweeted all kinds of nasty, racist, insulting, misogynistic tweets. And this being an AI, it just picked up on that and started tweeting in the same style. Like, we are going to build a wall and Mexico is going to pay for it. So it took less than 24 hours until somebody pulled the plug and Microsoft Tay went offline forever. And Microsoft had to excuse for all the stuff that this AI posted on Twitter. So this is another example on how AI can go wrong. You cannot just write an AI like a chatbot and leave it running out in the wild. This is something that needs constant surveillance, maintenance, fine-tuning, and so on. A bit later that year, Microsoft came up with a much more controlled AI, Microsoft Zoe, which would talk to people about stories they would want to write. And they really limited the possible responsive that Zoe could give them. So lived on for a couple of whiles, but never really became that famous. I think the last instances that were still running online were shut down in the last year in 2020. I think it's not online anymore at this point. So let's go back to the very beginnings, to ELIZA, which came out in 1966, and look at how ELIZA works. I recommend you have a look at this original paper from the inventor, Joseph Weizenbaum, which you can find here, but I'll show you the basic principle. So the core idea is the one written here. You write some input to ELIZA, and then these input sentences are analyzed on the basis of decomposition rules, which are triggered by keywords appearing in the input text. Responses are then generated by reassembly rules associated with selected decomposition rules. So to understand this, let's look at an example. So first, before we look at the example, ELIZA actually has two parts. There's sort of the engine, the ELIZA engine, and then there is the set of rules. These decomposition rules, reassembly rules together with keywords. And in the example that we're looking at here, we're looking at this doctor script. But instead of a doctor script, you could feed the engine with different rules, different keywords, and then you have a different bot. So here we are usually talking about this combination of the ELIZA engine with the doctor script. So let's say you write something like this: I am very unhappy these days. And then a response that you get out, a bit depending on the script, but the original script would give a response like this: how long have you been very unhappy these days? So how does this work? First, it finds out a keyword. So the system has a list of keywords, and I am is one of these keywords. Then it has a decomposition pattern that it will apply to the sentence. So this keyword will trigger the decomposition pattern. Let's say we are picking the pattern I am followed by whatever. And then for this decomposition pattern, there is a corresponding reassembly pattern. And the reassembly pattern is to print out how long have you been, and then whatever, where whatever is exactly what you cut out here. So if you apply this here, very unhappy these days is our whatever. And then the response is how long have you been? And then whatever is very unhappy these days. And this is how you get the answer. So this, in short, is how ELIZA works. There are a few more sophisticated rules, and it doesn't always pick the same pattern. You can have multiple decomposition patterns so that it doesn't give always the same response, and also multiple reassembly pattern. So it doesn't look like robotically giving always the same answer for the same question, but you get as an idea on how this works. In particular, you can see that this was developed in the early 1960s on hardware that was available there. ELIZA as a bot doesn't really understand anything. It doesn't have any concepts. It doesn't understand your conversation. It just blindly applies these string matching patterns. But still, a lot of people, when they talked with it, they were very impressed and thought they are talking to a somewhat intelligent system. Coming to something vastly different, IBM Watson was developed starting in 2006, and then in 2011 was the famous Jeopardy competition where it was made public. So this is another type of chatbot, more precisely a question answering system, where a question comes in. Even in Jeopardy, it's a type of question, even though the game show has this funny idea of giving the answer and you provide the question, but it's still the same thing. The question is going to be analyzed, and then based on the question is going to generate multiple hypotheses. And then for each of these hypotheses, it's going to generate answers. So it has multiple knowledge bases that it has available. Then in parallel, it's trying to generate multiple answers, and then it has kind of a scoring algorithm. And then it sort of picks the answer it thinks is the best one based on a scoring algorithm. And all of this has to happen very fast. Yeah, in the game show, it has to happen in real time. So all of these knowledge graphs, knowledge bases have to be kept in memory. So this system, this competition was 10 years ago, and it was running on hardware with 2,880 separate cores, all based on the PowerPC architecture. And the system it was running on had 16 terabytes of RAM. Not 16 gigabytes, 16 terabytes of RAM. So even though this is 10-year-old hardware, it's still quite impressive. So obviously, IBM didn't spend half a decade of a whole research team and millions on hardware just to win a game show. Watson is now one of their products that you can use for a paid question answering service, so kind of a web service, and adapt it for your company. And they sell it for various applications, for example, in hospital applications for answering medical type questions. So let's look a bit at the landscape of chatbots. So as you've seen yourself, this is something that has really exploded in the last couple of years. And as I mentioned before, there is not a single technology, a single library for building these bots. They have a huge scope in terms of complexity. If you compare IBM Watson against something like ELIZA, so there is a huge scope in terms of implementation techniques. At the very core, you have some kind of system you use to interact with the chatbot. And nobody wants to install a different kind of messenger just to talk to one specific agent. So these have to integrate with one of the existing messenger or social networking systems, like email, Twitter, Slack, chat applications like Telegram, WhatsApp, Line, messengers like Zoom or Skype, and so on. So this is sort of the core technology. These bots have some way to interface with an API. Then when you build them, you're using some kind of library for various techniques like natural language processing, analysis of maybe spoken language, and so on. So here, there again is a huge scope, and you can distinguish, like we talked for NLP earlier, into libraries that you use yourself and build an application on top of it. For example, AI libraries, TensorFlow, Torch, and so on. And you can also use managed web services. Now, all kinds of companies give you either generic APIs for language analysis or APIs specifically for developing chat applications. So again, in the last couple of years, there have been a huge number of providers, startup companies, established tech companies that build APIs or libraries for building chatbots. Essentially, they offer you two different services. Either they build you your own chatbot. So there are lots of startups that you can go and say, okay, I need a chatbot for my specific application. And then they will build you a bot based on your specifications, including, there are startups, including some well-known ones in Montreal that would build these bots for you. There are also the established tech companies, like IBM with Watson, that you can customize to your specific domain. So again, you have the scope of either build something built for you that you run then in-house, or you have something that you deploy on a cloud provider, like on IBM or on Amazon, Microsoft, and so on. And then finally, you have all the companies that use bots. And you've probably seen that there are more and more companies integrate these bots into the user interface, whether you go to your bank or a hotel or a reservation website, almost everywhere you'll find these bots. They have a very different scope. Some of them are really basic. It's not much more sophisticated than kind of a menu system. Press 1 if you want to check this, press 2 if you want to change that. This is obviously a lot simpler to build than something that understands natural language. But basically, nearly every company that has some kind of online presence is working on or already has some kind of bot. And a reason is that this is one of the major emerging technology. Back in 2018, it was one of the top 5 emerging technologies identified by the Gartner consulting agency. And they predicted then that 25% of all the customer service operations will use some kind of virtual assistant. And they predicted that the whole market of this would reach $1 to $3 billion by 2025 and contribute to a huge growth ratio. Essentially, the idea is that these bots, they can deliver huge benefits for a company across multiple different disciplines. For example, for sales, for marketing, for managing human resources, operations inside a company, for service. If you have customers that have service questions, payment questions, all of these could be at least partially handled by a bot. So it both improves the quality of interacting with the customer. Instead of waiting for a couple of hours, you have a bot that you can ask directly. And for the company, it also has the potential of saving human resources, because one way of setting up these bots is that now you can have the bots as the first interaction to a human question. And only when the bot doesn't know the answer anymore, then it would sort of hand over the question to a live human in the background that would take over the chat and answer the question. But then one human can supervise, let's say, 100 bots or even more, because the human would only handle the question that the bot can't answer anymore. So here we come back sort of to the ethical question of AI. Now you can build bots that replace humans, but this has obviously the problem that now humans are out of employment and have to do something else. So there's an ethical question related to it as well. So this sort of motivates, and you can see why more and more companies want to have some kind of bot. Very often they start with a very simple bot and then over time change it, improve it, adapt more sophisticated AI techniques. So this is of course, it's a programming question. And in this course, we learn how to build a bot of different complexity. But for a business adapting a bot, this is a lot more complicated because you read a real business case behind it. Now you have to say, what kind of use case is this bot supposed to handle? How do you evaluate the performance of this bot? What kind of risks are associated with it? If this bot gives a bad answer, in the context of a bank, for example, this could be a huge risk. This is something that goes beyond just the technical questions of how you implement a bot. And then for a company, the question is, do we build this ourselves? Do we select a vendor? Do we go to a consulting company to have one of these built? And as you've seen in the bad example with Microsoft Tay, you cannot just build a bot and leave it running. There is a life cycle of supervision, retraining, redeploying. So there's a very complex business case behind building these bots. So to summarize this third part, one of the topics in this course is building intelligent agents as an example of an intelligent system. And this is sort of the application layer on top of the technologies that we learn, like knowledge graphs, knowledge-based queries, natural language processing. And this is interesting because this is also a very hot topic from the business side. But it doesn't come out of nowhere. As you've seen, the AI research started in the 1960s. It became It started to become commercial in the 1990s, and then over the last 10 years, the technology has become mature enough that we now have this huge increase and explosion of AI-based intelligent assistants. Specifically to bot, you have seen that there are very simple ways for building a bot, like the early ELIZA with some very simple rules. And this can go on to a lot more sophisticated techniques like an IBM Watson. But these bots also bring new issues in terms of legal and ethical questions. You have probably all heard about the discussion that Twitter has a huge amount of bots, for example, in political campaigning that just send out messages and interact with humans. And some even say that now there are more bots talking to other bots on Twitter than there are actual humans having conversations on Twitter. Think about bots that pretend to be human, or bots giving medical advice, saying something about inoculations or how to recognize a disease. Just because you can build a bot doesn't mean there are not huge ethical or legal questions that you now have to consider. Okay, so this brings us to the end of our introductory lecture. I'll tell you in a second what you should do now before we come to the next week. But essentially, now you should have a somewhat better idea what the course is about, what kind of technologies we are going to cover, what you have to do. For each lecture, I'm going to give you reading and additional resources, usually split into something that's essential, that you must have read, and additional information that's sort of on a need-to-know basis, either because you want to refresh some background or you want to read some additional information. So here, because this is an AI course, you should read one of the introductions to AI. There are a lot of introductions out there. I picked one here, which gives a good overview of AI and the history. We talked about ELIZA. The Wikipedia page gives a good summary on how ELIZA works. And for contrast, also have a look at the page explaining how Watson works. And go to Moodle and have a look at this video of Watson competing in the Jeopardy competition. Here are some additional links for some of the things that I've shown you on the slides, like for all of these different ways of implementing a bot. This is described in this article here. If you want to know a bit more about NLP and machine learning in bots, have a look at this link here. And the details behind Watson, you can read in this article here. Even if you don't understand all the technologies yet, might be interesting to browse through it. And you'll see once we come to roughly the middle of the course, you'll have a much better idea on how a system like Watson is working. Okay, so this brings us to the end, and I will see you again next week. Bye-bye.